Hello all, myself Sambasiva Rao, working as Assistant Professor in the Department of Civil Engineering at VNR VJEC. I welcome you all to the lecture series on payment materials, and the topic of discussion for today will be tests on aggregate. So the first test is regarding the aggregate crushing value. Before this, we have already discussed the shape test on aggregate, which is a preliminary test before proceeding for tests on strength. So that is a preliminary test which is supposed to be conducted in order to ensure that whether we need to conduct the strength test or not. If the aggregate have failed in the shape test, then we have to discard the material and we need not to conduct the strength test. So after the aggregate have fulfilled the criteria in the shape test, either in terms of flakiness index, elongation index, or angularity number, then we have to proceed this set of tests which we are discussing today. And the first test is nothing but aggregate crushing value. So the aim is nothing but to determine the crushing value of the given aggregate sample with compressive testing machine. So and the equipment which is necessary, the apparatus which is required is nothing but aggregates stone sample along with the set of sieves, 12.5 mm sieve and 10 mm sieve. The aggregate passing through 12.5 mm sieve and retained on 10 mm sieve have to be collected. Along with, after testing, you need to have 2.36 mm sieve along with the pan, and there is a cylindrical measure to measure the amount of the aggregate which need to be considered for testing, along with the cylindrical mold which is used for testing the aggregate in the compressive testing machine, along with the plunger which is placed on the cylindrical mold. So here only the size of the aggregate which are passing through 12.5 mm sieve taken into consideration, because these are the aggregate which gives consistent results while testing and are also will have better reproducibility. So that is why the reason we are going to have the aggregate which is passing through 12.5 mm sieve and retained on 10 mm sieve. Higher size of the aggregate will give erroneous results, along with the smaller size of the aggregate also will give higher aggregate crushing value when subjected to this crushing value test. So the prime requisite for conducting this test is nothing but you have to take the aggregate of 12.5 mm passing and retained on 10 mm. Then the aggregate has to be woven dried. So the aggregate have to be woven dried for a temperature of 100 or above degrees centigrade, and then this test is to be conducted on the aggregate. So you have to take the aggregate, and this cylindrical measure is very important. So here the volume of the aggregate we are testing remains constant, because we cannot rely on the weight of the aggregates. So here the volume of the aggregate is very important. Irrespective of the size of the aggregate, we are going to take the unit volume of the aggregate what we are testing. So this is a cylindrical measure which I am having over here. Okay, so this is of height 18 centimeters and a diameter of 11.5 centimeters. So this is a cylindrical measure. So this unit of volume is very important. So we have to take the volume of the aggregate which are filling this cylindrical measure, and while taking this cylindrical measure you have to take the aggregate again 12.5 mm passing and 10 retained. You have to fill up to the 1/3 of this cylindrical measure, and you have to give number of blows, 25 number of blows with this tamping rod provided over here. So this is very important. So in order to have better compaction with the volume of the aggregate, so you have to fill up to the 1/3 of the aggregate and you have to give 25 number of blows. Again fill another 1/3, like that you have to do the 3 times. Once after that you make sure that no aggregate is coming outside of this surface of this cylindrical measure. So that gives rise to the ensuring that the aggregates are full in compacted condition with the fixed volume whatever we are having. After this aggregate has to be transferred onto this cylindrical mold. So we are not going to test this cylindrical measure. Instead we are transferring this aggregate onto the cylindrical mold which is provided over here. I did not get the cylindrical mold because of its huge weight in condition. So the aggregate sample from this cylindrical measure has to be transferred into the cylindrical mold or provided over here. So this is going to have a base plate over here, and the diameter of this is 15.2 centimeters. So we are having internal diameter. So this is very specific. The internal diameter is 15 centimeters and the height is 14 centimeters. And you see a plunger over here. The plunger is placed onto the cylindrical mold. So the diameter of the piston of the plunger is 15 centimeters, so that it goes and settle onto the top of this cylindrical mold. So then this entire setup, the cylindrical mold which is filled with the aggregate. Again, while transferring the aggregate from the cylindrical measure onto the cylindrical mold, you have to give again, you have to fill that in 3 layers with the 25 number of blows. And after that, so this piston, this plunger along which is provided over here has to be placed onto the top of the cylindrical mold, and this entire setup is placed into this compressive testing machine apparatus. So this is by means of hydraulic jack. So the load will be supplied from this the head load will be supplied from this mission to this equipment over here. So and the amount of the load which is applied over here in terms of the aggregate crushing value test is 40 tons, or sometimes you might be seeing this as 400 kilonewtons also. Okay, and the rate of loading is 4 tons per minute. So that is nothing but an average. You have to apply 4 tons per minute. So approximately the test will be will consume a time of 10 minutes, such that 10 into 4, 40 tons overall load. So again, there is a lever onto this where we have to go for loading, unloading condition, and whatever the amount of load you are required, you can be applied to this compressive testing machine. It is very simple. You have to provide that cylindrical mold into this location wherever it is provided, and after that you are going to apply the amount of load that is required. So because of this, once the very important thing over here is nothing but the type of the load what you are applying in the aggregate crushing value test is gradual load. So you are increasing the load gradually. So this is a simulation of the load which is applied onto the top of the pavement gradually. So this is one table what you can see over here for calculating the aggregate crushing value. So this is the 12.5 mm sieve and this is the 10 mm sieve, the aggregate initially what we have taken, and you have to take the weight of the aggregate sample in the cylindrical measure. Okay, that is represented as W1, excluding the empty weight of the cylindrical measure. So previously I have shown you a empty cylindrical measure. So you have to exclude the weight of the cylindrical measure while taking the weight of the aggregate. If you by default, if you have taken the weight of the cylindrical measure, so you take that as capital W, and again you take the weight of the empty cylindrical measure small w, and that the difference will give rise to capital W1, which is nothing but weight of the aggregate from the aggregate present in the cylindrical measure. I repeat, so this is nothing but the weight of the cylindrical measure along with aggregate, and this is weight of the empty cylinder. So this is the weight small w empty cylinder. From that we are going to get the weight of the aggregate in the cylindrical measure, which is filled in the cylindrical measure, excluding the weight of the empty cylinder. So that is nothing but capital W1. And after that you have conducted the test aggregate crushing value test, and after that we are, because of the disintegration of the aggregate because of the applied load, so this aggregate have the tendency of breaking into small pieces. So as a result of that, some part of the aggregate will be become fine powder, and which will be passing through 2.36 mm sieve. So for a good quality of the aggregate, the amount of material passing through 2.36 mm sieve should be as low as possible. Why? Because if the aggregate has undergone disintegration a huge amount, it means nothing but the aggregate is not in good condition. So that is what we have to understand in terms of aggregate crushing value. So I've got some values over here for our understanding. So you have to repeat this for at least 2 trials, trial 1 and trial 2. So I have taken the weight of the aggregate, which is nothing but the weight of the aggregate which is filling in the cylindrical measure, which is nothing but 2695 grams. So this is the amount of the weight which I have, the empty weight of the the weight of the cylindrical weight of the aggregate filled in the cylindrical measure, and the weight of the aggregate which is passing through 2.36 mm sieve after the test has been conducted, it has turned out to be 608.5 grams. So as a result of that, there is a formula over here, so which is nothing but aggregate crushing value is nothing but aggregate crushing value ACV is equal to W2 divided by W1, which is nothing but the weight of the metal that has become fine powder less than 2.36 mm sieve and the initial weight that I have taken. So this value is very easy, 608.5 divided by 2695. So as a result of that, you are going to get 22.57% as the aggregate crushing value. So this is the process how you conduct the aggregate crushing value and how you tabulate the readings. If required, you have to go for another trial, second trial, and you have to report the average crushing value of 1 and 2. So the next test what we are going to conduct is nothing but aggregate impact value test. So the aim of the apparatus is nothing but to determine the impact value of the given aggregate sample. Again, the size of the aggregate remains constant. So the aggregate passing through 12.5 mm sieve and retained and 10 mm sieve. Only the mechanism of the load application will be different. Previously it is nothing but gradually applied load, and in this condition we are going to apply the impact load, because we see that the aggregate will be subjected to different mechanisms of the load. Some part of the aggregate will be subjected to gradual applied load where the vehicle is in continuous contact, or some part of the aggregate will be in contact, will be subjected to impact loading condition when the vehicle is jumping on the speed breakers, or sometimes during acceleration and deceleration characteristics, or some other reasons. So it might be subjected to impact loads. So that impact cannot be generated directly like this what we are giving hammer. So some kind of simulation what we are doing is nothing but we are giving impact load that is being subjected to some amount of load that is applied from particular height. So that is what the impact what we meant to be here. So here the equipment is nothing but there is a lifting handle over here and there is a release pin over here. So there is a release pin. Once you release that pin, so then only you can be able to apply the load of the impact load onto the aggregate. So here also we have one is nothing but cylindrical measure over here, and again this is cylindrical mold which will be placed into the equipment provided over here. So again we have a hammer which is of 132 to 137 newtons, approximately this will be of 14 kS, and the height of fall is already given over here, so this will be 380. So height of fall will be 380 mm in this case, and the weight of the hammer will be 14 kg. And this again the weight for selecting 14 kgs is a replication that higher the weight will be having a huge effect on the aggregate, or less amount of weight will have negligible effect on the aggregate impact. So as a result of that, in order to simulate the field conditions, this value of 14 kS and the height of fall as 380 mm has been selected. Again the height is selected as in order to generate the amount of the energy, that is energy in joules, that is applied onto the aggregate present over here. So in order to simulate the field conditions. So the cylindrical measure, so this is the cylindrical measure which I have got over here. So this you can see the cylindrical measure just like the previous condition in terms of the aggregate crushing value. You can see this. This is again 75 mm dia. And again a height of 50 mm. So again you have to take the aggregate which is passing through 12.5 mm sieve and retain in 10 mm sieve. Again you have to fill this in 3 layers. After this, while filling in 3 layers, again you have to compact this with tamping rod previous provided over here. This tamping rod is of 1 centimeter diameter, and this is of 15 or 20 centimeters in length. Previously the tamping rod which we have used in aggregate crushing value test is somewhere around 60 centimeters, which is nothing but 2 feet, and the diameter is 1.6 centimeters. But whereas this is 1 centimeter diameter and this is 230 millimeters, and the cylindrical measure is nothing but which is of height 50 mm and diameter of 75. You need to fill the aggregate of 3 layers. Again you have to compact this with 25 blows, and after that you have to transfer. I have got the cylindrical mold because this is a little bit smaller when compared to that of aggregate crushing value. So whatever the aggregate you have taken previously here, so again at the top condition you have to see that there is no aggregate which is protruding outside of this surface layer. So after that you have taken this required amount of volume of material. This amount of aggregate has to be transferred into the cylindrical measure provided over here, and this entire setup which is the cylindrical mold has to be shifted to this location. So this is need to be placed under the impact load or the impact testing machine which is provided over here, such that, and that is need to be gripped to the base of the impact testing machine. And after that you are supposed to apply the number of blows which is nothing but 15 number of blows onto the aggregate. Very simple, as simple as that. So the same process as that of aggregate crushing value, you have to fill the aggregate in 3 layers in a cylindrical measure, such that you are going to ensure a fixed volume of the material, and that material is transferred into the cylindrical mold, and then it is subjected to the impact load. So you can see that this is the height of the cylindrical mold is also again 50 mm. So the height of the cylindrical mold is 50 mm and the diameter is 102 mm. So because the diameter of the hammer you can see over here, it is 100 mm. So in order to in order to make sure that the hammer go on present or will be accommodated inside the cylindrical mold, so that we are going to provide 2 mm extra. So this is the clearance that we are going to provide, and then this has to be subjected to 50 number of blows. Again, as a result of that impact load, so the aggregate will be crushed into powder. So again the same thing. So you have to take the aggregate which is passing through 2.36 mm sieve, and the process is as similar as that of aggregate crushing value. We have to take the weight of the aggregate sample in the cylindrical measure, so aggregate alone, so which is nothing but 3.7 kg, 3.7 grams in this kg in this condition. So I have taken the aggregate which has filled in the cylindrical measure, and that has been transferred into the cylindrical mold, which has come to be 307 grams. And after that it is subjected to the impact load, and after that the amount of material which is passing through 2.36 mm sieve has turned out to be 40 grams. So again the formula is nothing but W2 by W1 into 100. So again you have to repeat this for 2 trials in order to get the average value, but I went for a single value which is nothing but 40 divided by 307. You can calculate the value of this to get the aggregate impact value test. Next one is Los Angeles aberration value. So this is another test which is conducted on the aggregate. So you can see that there is a drum present over here. So this is Los Angeles aberration drum which is used to conduct the aberration test. So this aberration test is nothing but wear and tear. So that is nothing but you have to understand what is the rubbing action that is happening between aggregate and any other metal which is coming into the coming in contact with the aggregate surface. So this is the cross section of the drum, you can see over here. So these are the particular dimensions over here, and you have to, there is a opening for the cylindrical drum like this. So you can release this part of this lid of this cylindrical drum, and you can put the amount of weight of the metal whatever is required, and you need to apply some amount of abrasive charge over here, because the aggregate alone will not be having that much effect in the abrasion process. So that is why we are also going to add some number of abrasive charges in order to have the effect of rubbing action. So this is a general, unlike aggregate crushing value test and aggregate impact value test, the size of the aggregate here is not fixed. We can conduct this test starting from the aggregate size of 80 to 63 mm to as small as 4.75 to 2.36 mm sieve. So this up to this is the range of aggregate where you can conduct this aggregate abrasion value test. So based on upon the grading, so if it is grade A, so we have to select these 4 grades of the aggregate, 4 sieve sizes, which are nothing but 1250 grams of each, such that it will become 5 kg, and the abrasive charge which you are supposed to use is nothing but 12 number. So I've got the abrasive charge over here. So this is like a small ball which is nothing but of steel, and it is having a diameter of 48 mm diameter. Okay, and is having very approximately very close to that of half kg weight, so somewhere around 455 grams like that. So this abrasive charge you have to put along with the aggregate into the cylindrical drum. So you can see that again grade B, you can see that the aggregate are passing through 20 and 12.5, which are nothing but 2500 grams each, and followed by aggregate C, gradation C, which is nothing but 2500 grams of each of weight. So passing through 10 and 6.3 retained, followed by 6.3 passing and 4.75 mm retained. So otherwise again you have the aggregate gradation of D gradation along with E gradation and F gradation, and followed by G gradation. So the abrasive charges, number of charges you have to use is nothing but it has been mentioned over here. So that is the based on upon the type of the gradation you are using, you have to select the number of required abrasive charges. And here very importantly, when you are using the aggregate gradations of ABCD grading, you have to go for 500 revolutions. So the number of revolutions, so previously we have seen a drum, so which will be revolving around its cylindrical, so this is the horizontal axis, and this drum will be revolving around the cylindrical, this horizontal axis. As a result of that, the aggregate, which is the aggregate present over here, once it comes over here, it is going to jump over here. So it is, combination of both impact and impact. So it is impact as well as impact load. So these are the different gradations what we are going to add up. According to your requirement, you can select any grade, and you have to select the number of steel charges, and you have to subject the abrasion machine to number of revolutions as per your convenience, as per your requirement. Either if it is ABCD grade, you have to go for 500 revolutions. If it is EFG, you have to go for 1000 revolutions. And you find out again, instead of using 2.36 mm sieve, you have to use a 1.7 mm sieve, because unlike aggregate crushing value and impact value, here the aggregate is not just breaking over here, only the aggregates are being subjected to rubbing action. So once the aggregate are subjected to rubbing action, so it results in the formation of fine powder, or a little bit small higher amount of dust, or some amount of rock dust, but whereas it won't have the size of 2.36 mm sieve. But here, after conducting the test, it is very difficult to find out the amount of metal which is passing through 1.7 mm sieve. So for which we are going to find out the material which is retained on 1.7 mm sieve. So whatever the weight of the material what you have taken, so here I have taken the weight of the material, some gradation of this gradation D, so I have taken 5000 grams over here, and the weight of the metal retained on 1.7 mm sieve. Initially we are interested in calculating the weight of the metal passing through 1.7 mm sieve, but I have calculated, because it is very easy to find out the weight of the metal which is retained, because some part of the metal passing through 1.7 mm sieve may be present inside the drum also. So it is very difficult to get that material, and there will be some error in reporting the results. So as a result of that, we are going to calculate the weight of the metal which is passing through 1.7 mm sieve. So that has come to be 4458 grams. So the difference of that, so the weight of the material passing through 1.7 mm sieve has come, and this is the original weight we have taken. So therefore the weight of the material indirectly can be reported as this weight minus this weight, which is nothing but 542 grams. So then if we can report this W3 by W1, which is nothing but 10.8 percentage. So this is the weight of the abrasion value. So I am writing over here, this is the 10.8 is the Los Angeles abrasion value for the aggregates what we have taken. So either again aggregate impact value or crushing value or this abrasion value, you have to take the aggregates which are heated to 100 and 110 degrees centigrade in order to make sure that this is free from moisture, and you have to do this test for 2 trials in order to get the average value. So we are going to compare all the 3 tests what we have discussed so far. One is nothing but aggregate crushing value, aggregate impact value, and abrasion value. So the type of the load is nothing but gradual compressive load. This is nothing but sudden shock load or impact load, and this is nothing but rubbing action or impact load. So this is nothing but again rubbing along with impact. So it is having some part of the impact. Nature of the stress is nothing but it is static load or slowly applied. So even though it is gradually applied, it is very slowly applied. So at a rate of 4 tons per minute, such that we attain a value of 40 tons. So this is dynamic, and we are going to apply number of blows as soon as possible in a short duration, and this is nothing but repeated process, and which will be subject to rubbing action between aggregates and steel abrasive charge. So the traffic action simulated, this is a reflection of aggregate crushing values, a reflection of the steady wheel load which is moving onto the surface of the pavement. Along this is nothing but wheel hitting due to irregularities or the potholes or the speed breakers, whatever it is, and also the effect that is being generated due to acceleration or deceleration of the vehicle. And this is the tire and aggregate rubbing action, or some any material which is coming in contact with the aggregate particles. So that is the type of the traffic action simulated over in terms of abrasion test. So permissible values are nothing but again we all know that the top layer of the pavement is very superior quality of the material, is made up of very superior quality of the material, and we expect that it should have very lesser values of aggregate crushing value, impact value, or abrasion value, because lower the value of this aggregate crushing value or impact value, then better the aggregate. So for varying course, so you are supposed to have the value less than 30% in terms of aggregate crushing value, and these values are should be less than 45% in terms of base course, and these values are again relative values. So different codes specify different values. So these are the tentative values which you are supposed to remember. And aggregate impact value test, again 30% for surface courses or varying courses, and base course it can go up to 50%, followed by abrasion value, it should be less than 35% for surface courses, and for base courses it should be less than 45%. Very important thing is nothing but the core property what we are testing in each of the test what we are discussed so far is nothing but in terms of aggregate crushing value, we are going to see the strength of the aggregate. So it means nothing but what is the maximum load that an aggregate can bear just before failure or up to failure. So it means nothing but it is keep on taking some amount of load, and what is the maximum load that it can bear just before failure or up to failure. So that is why it is nothing but the strength. There has been a number of times this question has been asked in competitive examination. What is the core property that has been tested in the form of the question has been asked in the form of matching. So what is the core property in terms of aggregate crushing value? It is nothing but strength. And next one, aggregate impact value test, it is nothing but toughness. So resistance to impact loads are nothing but toughness, and followed by resistance to rubbing action is nothing but wear and tear, it is nothing but hardness. The other test what we are going to discuss on aggregate is nothing but specific gravity and water absorption. So it is an indirect way of having an understanding of the strength of the aggregate. Along with this, we are also having the specific gravity is very important in calculating the volumetric properties of the bituminous mixtures what we are going to generate out of this aggregate which we are using over here. So the aim of the test is nothing but to determine the specific gravity and water absorption of the given aggregate sample. So the definition of the aggregate specific gravity is just like this. So which is nothing but specific gravity is nothing but weight of the substance, that is nothing but weight of the unit material divided by weight of equivalent volume of water. It means nothing but, for suppose I have taken this is the some weight of a substance. This is nothing but let it be an aggregate particle. So the numerator will be the weight of this substance as it is, and the denominator is nothing but weight of water whose volume is equivalent to the volume of the aggregate present over here. So it is nothing but we want to find out what is the volume of weight of the water, but whose volume is equivalent to this volume of this aggregate. So that is what in the denominator. So that is what the specific gravity it is. It means nothing but we cannot calculate the weight of the equal volume of water, for which we have to go for finding the weight of this aggregate in saturated condition or in water. So you have to take this in water. So you have to take this aggregate particle over here, and the weight which is acting on the aggregate particle in the downward direction is self weight of the aggregate, and there is a force which is acting on the aggregate particle in the upward direction, which is nothing but buoyancy force. So therefore you can represent it as weight in water. We need to get the what is the weight in water is equal to weight in air. So that is nothing but weight in air minus buoyancy force. Buoyancy force. Now we are looking for what is this buoyancy force. Weight of equivalent volume of water is nothing but this is what the buoyancy force. Therefore buoyancy force BF is equal to weight in air minus weight in water. So that is being represented over here. So this is what specific gravity. So that is what the definition of specific gravity. I repeat that it is nothing but weight of the unit material divided by the weight of equivalent volume of water. So this also can be written as so specific gravity is equal to weight in air divided by weight in air minus weight in water. But this weight in air which is represented over here, it is an important parameter which is variable over here. So this weight in air is going to remain constant. That is nothing but weight of the woven dried aggregates which remains constant in different conditions. But this weight in air is a different condition which is nothing but where we are calculating the weight in air respect to the different volume what is going to be considered. So these are the conditions which we will be encountering in calculating the specific gravity of the aggregate. So this is nothing but woven dry aggregate. Let us assume that there is an aggregate particle which is like this. So there is a surface force like this. So here there is a surface force, this is a surface force. So this is nothing but so the apparent volume, whatever this aggregate what we are having, this is nothing but the apparent volume. So this is the apparent volume. But if you fill this like this, if you close this entire aggregate particle, that is said to be the bulk volume of this aggregate. So this is nothing but initially this is nothing but apparent volume, and now if I cover this is nothing but a bulk volume of the aggregate. So now again I am dipping this aggregate into the water. So in order to get the weight in water, so that is nothing but the buoyancy force, and after that again some your aggregate will be coated with water, and there will be some amount of water film which is present in the surface of the aggregate, and you are going to really remove this water film on the surface of the aggregate. Then you are going to get the saturated surface dry. The surface is dry, but the aggregate is in surface saturated condition. The aggregate in saturated condition. This is nothing but woven dry condition. This is nothing but wet surface when the aggregate is present, just taken immediately outside of the water measuring device. And this is nothing but the saturated surface dry. Saturated surface dry. Once you have taken this aggregate out of the water, then you have to rub the surface with a cloth, a dry cloth, such that only the surface of the water film will be removed, but the aggregate will be still in saturated surface dry condition. So here now the specific gravity is very important. Here we are going to have different specific gravities over here. One is nothing but apparent specific gravity, one is nothing but apparent specific gravity, next one is bulk specific gravity. Okay, I repeat, as which is nothing but apparent specific gravity, and next one is specific gravity which is nothing but bulk specific gravity. So here the weight of the air, the weight in air will be remains constant, which is nothing but the woven dried aggregate weight, and in the denominator which is nothing but weight in air minus weight in water. Again this weight in water is also going to be remains constant. The only thing which is going to keep on change is nothing but weight in water, weight in air in the denominator respect to the volume. So if you are taking the saturated surface dry volume, this is nothing but W3, which is nothing but the saturated surface dry weight, and this is nothing but again W4. If you want to take the apparent specific gravity, so this weight will be W4. So in terms of the here the weight in air is a different criteria. It is going to change with respect to the volume what we are going to consider. In terms of apparent specific gravity, the weight is in the numerator is nothing but the weight in weight of the woven dry aggregate divided by, so weight in air. In this condition you have to take the woven dry aggregate condition. So this is what you have to consider, because we are taking the apparent volume. So that is nothing but this is the only apparent volume what we are having over here. We don't want the bulk of the volume. So in that condition, in terms of apparent specific gravity, we are going to take the apparent volume of the material, which is nothing but W4, which you are going to get it from W4. And next one, in terms of the bulk specific gravity, what we are going to get is weight in air in the numerator divided by, so in the denominator this is weight in air, so which is represented as W4. I will be showing these values again later, and this is nothing but W3. because we are looking for the volume weight in air, which is nothing but the bulk volume of the aggregate. So that can be obtained from the saturated surface dry condition, so which is nothing but W3. So therefore your value will be W3 minus weight in water. So that is what you have to note it. So this you can see the different nomenclature which is present over here. So the weight of the saturated aggregate and basket in water, so which is nothing but W1, followed by weight of the basket suspended in water. So this is the wire basket which is present over here. Initially you have to take the weight of the aggregate of approximately 2 kg. Let us assume that 2 kg I have taken, and this will be 2000 grams. So I have taken a woven dried aggregate of 2 kg passing through 20 mm and 16 mm, retained on 16 mm sieve. This aggregate can be of any size. So I have taken the aggregate which is passing through 20 mm and retained on 16 mm sieve. That weight of the initial weight of the aggregate is nothing but 2000 grams. And after that, weight of the saturated aggregate and basket. So before that, taking the weight, I have to actually give some number of joules to that aggregate which are present in this basket in order to make that aggregate free from dust. So you have to pull this aggregate particles over here and into the basket, and you have to give some number of joules, somewhere around 20 number of joules, and that aggregate is left in water or kept in water for a duration of 24 hours, such that the aggregate is being subjected to some amount of water absorption, so that it will be in saturated condition. After that, next day you have to take the weight of this following values. So the weight of the initially saturated and basket in water, so that you have to note it. So even though the weight you have taken is 2000 grams and there will be some amount of basket weight, so that entire value turns up to be 2107 grams alone. So that is nothing but, because this is a weight in water, so the values is going to be lesser. Even though the value of aggregate plus basket is very high, so suspended weight will be less. And the weight of basket alone, basket suspended in water, is, it has turned out to be 860 grams. 866 grams. Next one, again weight of the saturated aggregate alone. So this minus this, you will get the value of this. So saturated aggregate, so this is nothing but 1241 grams. Next one, weight of water equivalent to the volume of aggregate. So this is nothing but so it keeps on changing. Weight of water equivalent to the volume of the aggregate. So I've told you this is in the denominator. So in terms of woven dry aggregate, this is nothing but the numerator. Already we have seen that. So apparent specific gravity is nothing but W4, which is nothing but the woven dry aggregate. It means nothing but once you have taken the aggregate out of the water and then you are wiping out the aggregate with the dry cloth, such that you will get the saturated surface dry weight. Once after I have taken the saturated surface dry weight also, which is nothing but in this condition it has come to be 2003 grams. So initially the weight of the aggregate I have taken is only 2000 grams, but whereas because of the surface being saturated, surface is dry, but the aggregate is saturated because of some amount of water into the pores. So the weight has turned out to be 2003 grams. And after that, again you have to keep that aggregate into the woven, and you have to find out the woven dried aggregate weight, so which will be less than of 2000 grams, and in this case it has turned out to be 1993.4 grams. So these are the different weights what we are going to get. This is W3 minus WS. So this is of no interest for us as of now. So this is either we have to take W3 or W4. It's a different story. This is W3, this is W3 over here, and WS is corresponding to this condition. Either it can be W3 or W4 according to the our requirement. So in the apparent specific gravity condition, we have to take the weight of the woven dry. As I said, in the numerator it will be a constant value, which is nothing but, so I'll write over here apparent specific gravity, ASG, apparent specific gravity, is equal to weight of woven dry aggregate W4 divided by, and here it is again W4, because I told you this is a condition which is representing the apparent volume. So this apparent volume is the volume which we don't want, the volume of the air voids, the volume of the pores. So that is why we are going to eliminate. That can be captured only in terms of this condition W4. So I am writing therefore the weight of the weight in air in the denominator also as W4, minus this nothing but W1 minus W2 is nothing but weight of the saturated weight. That is nothing but 1241 grams. So therefore I have arrived the value of 2.64 grams for the apparent specific gravity of the aggregate. And next one, we are also interested to calculate the bulk specific gravity of the aggregate. As I told you, the numerator will be W4, which is nothing but the weight of the woven dried aggregate divided by, and this denominator is nothing but weight in air, but this weight in air we want that corresponding to a volume of the bulk volume, not the volume of apparent condition. So this, therefore the weight in air in the denominator will be changed as W3, because we are interested in the bulk volume. So therefore W3 minus, again this remains constant, which is nothing but W1 minus W2, which is nothing but WS. So after, as a result of that, we are going to get the 2.61 as the value of the bulk specific gravity. So this is what you have to understand, the difference between apparent specific gravity and bulk specific gravity. The formula is the same thing, which is nothing but the weight in water divided by weight in water. The formula is weight in air divided by weight in air minus weight in water. But whereas the weight in air in the denominator condition is subject to the different volume conditions. If it is a apparent specific gravity, then the volume should be apparent volume of the aggregate. If it is a bulk specific gravity, then you have to take the volume of the entire aggregate, which is represented only in the condition of saturated surface dry condition. So the test methods what you are supposed to follow while conducting this aggregate tests are nothing but sieve analysis. So this we didn't discuss, but we have discussed this in shape test on aggregate, which is a very easy process. So you take the aggregate, you put onto the top of the higher sieve and make sure that the entire 100% is passing through that sieve, and you find out the weight of the metal retained on each and every sieve, such that you will get the weight of the metal passing through each and every particular sieve. Then you can calculate the cumulative weight passing through each and every sieve. Then you can plot the graph between cumulative percentage passing and the size sieve semi-log graph that can be obtained. So this is the sieve analysis graph, and just now we have discussed whatever it is specific gravity, water absorption. I forgot to discuss what is the water absorption over here. So there is another formula over here, which is nothing but the water absorption. Water absorption is nothing but the weight of the water. So weight of the water can be obtained as, so it is nothing but W3 minus W4. I'll erase this and we will discuss here. So therefore weight of the water absorption is equal to weight of water. If you look at the formula, weight of the water divided by weight of aggregate, which is nothing but woven dried aggregate, not the aggregate even we have taken 2000 grams, it is woven dried aggregate. So therefore weight of the water is nothing but, so W3, which is nothing but the saturated surface dry minus woven dried aggregate with respect to the woven dried aggregate. So in this condition the water absorption has come to be 0.48%. So the aggregate are in good condition as long as the water absorption is less than 2%. So therefore the specific gravity, water absorption and bulk density of the aggregate is conducted with respect to the IS 2386 part 3, and flakiness and elongation already we have discussed that, so which is the part 1 of IS 2386, and mechanical properties including aggregate crushing value, impact value and abrasion value, this with respect to part 4. And soundness test, we did not discuss this soundness test, so we'll just discuss this soundness test for a minute. Soundness test, or you can also call this test to be durability test. Durability test, a simple test which is need to be conducted over here. So you have to take the aggregate of any particular weight. Let us assume that I have taken the aggregate weight as 1000 grams, which is nothing but 1 kg, and then you have to see the effect of this weathering action. So whatever your mean here is soundness is nothing but you have to find out the durability, which is nothing but the weathering action, resistance against weathering action, which is nothing but either it might be temperature, pressure, or whatever condition it might be, weathering phenomena. So then you have to dip this aggregate into the solutions of NaSO for sodium sulfate, and next one is another solution which is nothing but magnesium sulfate. You have to take the aggregate and you conduct the test either according to your convenience, either whatever the solution it might be, sodium sulfate and magnesium sulfate. So you have to dip the aggregate whatever you have taken, and this particular both of the solutions or any one of the solutions, and this you have to keep it for 16 to 18 hours. So you have to leave that aggregate to be suspended in that solution for a period of chemical for a period of 16 to 18 hours, and after that you have to wash that chemical from that aggregate, and then you are required to oven dry the aggregate. So you have to oven dry this aggregate, and then you find out what is the weight. You have to find out the weight of the aggregate. After that it attains a constant value, and again you repeat the process. Again you dip that has completed one cycle, and again you go for second cycle. You put all the aggregate whatever it has come to you after weight loss, and then you put into the solution of sodium sulfate or magnesium sulfate, and again you leave it for 16 to 18 hours, and then you again wash it with water and for training condition for the removal of the chemical, and then again you oven dry it. So that is the completion of 2 cycles. So you repeat for 3 more cycles, such that you end up in doing the test for 5 number of cycles, and after that you find out the final oven dried weight of the aggregate after 5 number of cycles. So I have taken 1000 grams, and but the final weight is something, it has only it might be this is the initial weight I have taken 1000 grams, and somewhere around it might be 980 grams after weight loss, then divide by with respect to 1000 grams. So this will represent the soundness of the aggregate what we are conducting. So this is a very, very important. This is a representation of the durability test, and the limitations for having the value is nothing but it should not be more than 12%. So it should be less than 12% in terms of the sodium sulfate, and it should be less than 18% in terms of magnesium sulfate. as the sodium sulfate being harsh in nature, so we are restricting it to 12%. So if the 12% is being reached means it means nothing but the aggregate is not sound enough. So it is having porosity. But whereas it is allowed up to 18% because this effect of the magnesium sulfate on the aggregate is very less. So you can have somewhere around, you can go up to a higher value of 18%. So this is completion of the discussion on tests on aggregate. So I sincerely acknowledge the use of publicly available resources that supported and enhanced the visual clarity of this presentation. Thank you.
Like, share, comment, and subscribe VNR Digital Learning Resource YouTube channel.